Okay. All right, now here is a very important distinction that we need to understand. We talked about the difference between mutable and immutable objects, right? Now, another concept that usually used with this concept is the shallow copy versus deep copy. Okay, so that's not specific to Python. This is a general concept with any language. When we are trying to create a shallow copy, if we have something like this, just that. We have an object here. Okay, so if I want to create a shallow copy of that object, what does it mean? I only create, so here's a shallow copy. That's just another reference object. And because it's shallow, we just copy the reference, the memory address that is already there, and store it in the shallow copy. So at the end, we would have two references pointing at the same object. Okay, so that's the shallow copy. If I want to create a deep copy of X, can you guys see if I write here? Like here? No? Okay, so I'm just gonna keep it up there. Now, if I want to create a deep copy, it's not just a reference that I'm copying. Okay, we have to copy the reference, and we also, we have to create a reference, and what we actually copy is the actual object. So we create another object that has the same value that is a copy, but it is a different object. So it would have a different memory location. Can you see this? No. It's very difficult for me to find a way to a place that everybody can see. So let's say this is the, well, you know what? I'm gonna put it up. So this is the shallow copy. What about the deep copy? So the deep copy would be another reference here, but we don't copy the address that already exists. We actually create a new copy of the object, and because it's a copy, it would contain the original value. But this is a new object, so it has a different location. So let's say 2, 4, 5. So what's stored in the deep copy is a different address than the one in the original. Okay. So if I use the shallow copy to change an immutable object, what would happen? So if you remember when we talked about the changing a mutable object, we use the shallow copy to change a string. Let's say we're gonna append 1, 2, 3 to that string. Because the string is immutable, this change will result into a new object that has the new value appended to it 1, 2, 3. Because it's a new object, it will have a new memory location. So let's say this is 4, 4, 4. And the memory location, or the reference to the memory location, will be stored in the shallow copy, or the copy that I used to make the change. Did the original copy change? The original reference is still the same, and the original object is still the same. So when we use a shallow copy to change an immutable object, the change will only be reflected using the shadow copy, but the original is not going to change. Okay? Now, if I try to change anything through that original, that's a deep copy, a new copy will be created and stored here, so the original still remains the same. Okay? Now, if was the object mutable, if it was mutable, okay, so let's go back to the original state here. We're gonna see what would happen if the object was mutable. So the shadow copy had the same reference and pointed to the same object. If that object was mutable and we wanted to change through the shadow copy or through the original, doesn't matter, because the change itself happened in the object, right? So I change the object to append 1, 2, 3. Now, if I try to see the actual value through the shadow copy, the change will be reflected. If I use the original object, the change will be reflected. Because the reference didn't change, the actual object changed. And that object is shared among the copies. Okay? Now let's look at this example here. We have a list that has some mutable elements and some immutable elements. Okay? And we use the star to create a copy and concatenate the copies to each other. So let's see how does that look like. So right here we have an object called my list. Okay, so inside that list, I'm going to represent it by these 3 references. Okay, I have one reference to an object of type string, right? So let's say this is a 1, 2, 3 here. Okay, and then we have another object of type list, which is at this moment empty, but it's in a different memory location, let's say 4, 5, 6. And then, so this is pointing here. And then the last element is of type tuple, which is currently empty. So let's say 7, 8, 9. What happens when we create a repetition using the star? It creates a copy, a shadow copy of the original sequence, and then concatenate it to it. Okay, so the shadow copy would be something like this. A shadow copy of the first reference. So we copy the reference. A shadow copy of the second reference. And a shadow copy of the third reference. So just copying the reference itself, all the objects are shared. So what happens when we try to change an immutable object? So let's say I use the copy to change the mutable object. So what happens? It's going to create a new object. Let's say location 5, 5, 5. With the change, let's say A, B, C, D. And then that new reference or the new memory location will be stored in the reference I used to make the change. So the change I made will be only reflected if I looked at that copy reference. Yes. The string is immutable. Okay. So in the examples, I compared the mutable and the immutable cases, but in reality, the string is immutable. Yeah. So here, if I look at the list, the original list, I'll see the old value because it didn't change. But if I look at the copied list, I will see that the value changed. Okay? Now, what if I try to change a mutable object? So the list is a mutable object. We try to change that object, and it is mutable either through this reference or either through that reference. It doesn't matter because we go directly to the object and change it. So let's say we added 1 and 2 to that list. So both references pointing to the same object. So we will see that change reflected using both objects, both the references. Okay? Now what about the tuple? The tuple is immutable, right? So it would be exactly the same as the string. So let's say I'm gonna try to change it using the original reference. Okay, so when I try to change it, a new object will be created. So let's say I have a tuple with 2 values there. So, and this is 4, 4, 4. So the reference here will be replaced by the reference to the new object. But the copy remains pointing at the old object. So the change here will not be reflected at all the copies. Okay, so that's what we see here. That's what we see here. I created a repeated list using the star operator. So that creates a chapter and concatenated 2 times. All right. So here we have 2 copies that are shared copies. Okay. Now, if I try to change the first string here, the string that is available at index 0. Now, string is an immutable object, so it will create a new object and change the reference at 0 to that object. But the copy remains the same because they're pointing at the old object. Okay? Now, what happens if we try to change a list? So here we took the reference at 1, which is the list, and appended x, y, z. Now you can see both copies will be having the new value because we didn't change the reference is still the same, but we went to the object itself and changed it, and all of them are pointing back. Okay? Now, if I try to go to element 2, which is the tuple, so I'm adding a tuple there, I'm appending a tuple. The tuple is just like the string is immutable, so the change will only be reflected at the reference I used to make the change. This way. Any questions? All right, so yes. Yeah, so both sequence and tuple are. Well, let's try. I would think I would think they are mutable. I mean, immutable like the strings. Let's try. So let's say list equal 4, 6.5, and 10. And then I say list plus equal 2, and list. Okay, now what if I change the value at 0 to plus equal another 4? Yeah, so it's immutable like that. Yeah. All right, so that's all what we have for today. Thank you.